Hello everyone. Good morning. Good evening. Let me share my screen. So I'm Vijay Sharma. I'm your trainer for Docker and Kubernetes. So welcome to this second demonstration session on Docker and Kubernetes. So today's agenda is going to be why do we need Docker? And we will understand the history of the importance of Docker in software development lifecycle, why it has evolved, what is the need for it, and other things. So before I venture into that, anybody newly joined today, can you tell? I see Anand Kumar. Hi, good morning, Anand. Welcome to the session. Can you briefly put it in the chat? Oh, is my voice low? Okay, okay, let me just do one small update. Just give me a second, guys. How about now? Is it still low or is it clear now? How about others? Are you able to hear me clearly or still you feel that voice is a bit clear? You need more voice. I mean, do you want me to be more loud? Is it clear? Okay, cool, cool. Okay, fantastic, fantastic. So, so myself, Vijay Sharma, I have 12 plus years of experience in IT, and I'm a GCP certified professional cloud architect, and I'm working as a platform lead in a level 5 MNC. And this course is about Docker and Kubernetes in depth from scratch to advanced concepts I will be teaching you. So coming to the expectations of this course, I want you to be, with no prerequisites, at least a basic understanding of how, Linux works and maybe, working with some of the tools would be sufficient. If you even if you don't know Linux, that's okay with it. I want to make sure that this course has bare minimum prerequisites. Even a fresher or not even a fresher, a basic high school student should be able to understand our class and proceed with the class. That should be my goal. Okay, so it's a mixture of both absolute basics and advanced scenarios as well. So wherever you find hiccups or difficulty, just put it in the chat or raise your hand at the end of the class. I'll be taking your questions. So don't just interact with me throughout the course, and we will learn and we will progress. And one more thing I need from you is I will be providing you labs after the class. So please do the labs hands-on so that you will learn them and understand them better. So just listening to the class is only 20% to 30% of your concepts. But when you do the labs, it will help you in getting more understanding. And then when you go to the real world enterprise scenarios, and when you go to your own project, you will also have certain hands-on on the job learning. So it's not like one size fits all approach. So nobody can give you 100% of the information. So what I give you is sufficient to give you an edge over others in when you go to the project. And from there onwards, any customized every project will have its customized things. So you can quickly pick up from there and you can proceed. So that's my goal here. So Thierry, good morning, Thierry, and great. You have nice to know that you have knowledge of Linux and basic knowledge of cloud computing. That's sufficient. And by the way, if you don't know cloud, let's say you are a fresher to the cloud and you are absolutely no idea to cloud platforms like AWS or Azure or GCP, I will be providing you the documents to get uh, gets on speed with how to set up a VM in cloud, how to set up cluster in cloud. So I'll be providing you the necessary step-by-step documentation, so you don't need to feel that, oh, I don't know that, so will that be a problem? No, that shouldn't be a problem. But at any case, if you feel lack of anything, just let me know. So that's all from my side, and let's proceed to our session today. And thanks, Anand, and you are from Oracle Labs DBA. Great, great. Definitely, Anand. This course will definitely help you in propelling your career or switch your career as you wish. Okay, so let's go ahead, guys, and let's discuss about today's agenda for session. That is, why do we need Docker, and what are the problems does it solve? So whenever we go and understand a tool or a particular process, so we need to think in such a way that we what kind of problem does the tool addresses. Okay, so my basic philosophy is that whenever you want to understand any tool better, or any concept or any of the things better, you need to understand, without that tool, was there anything I miss? Or without the tool, what is the problem I am going to face? What are the challenges does the tool solve? So when you think in that way, the better you understand the tool, and you will be able to work with ease with that tool. So each of the tools we are going to learn in this course, the Docker, Kubernetes, and some more ancillary tools, all of them have been there in the industry, and they are here to solve particular problem. So now today we will try to understand, why does Docker exist? Okay, what problems Docker solves? So broadly, there are three uh, problems which we cat all the problems we categorize into three problems: the problem of isolation, the problem of environment, and the problem of speed. Let's try to understand from that perspective, what are these problems, how and how Docker, the evolution of Docker tries to solve these problems. Okay, let's try to understand one by one. Long ago, and so long ago, there were used to be mainframe computers. Still, mainframe servers are there, IBM servers are mainframe servers are there, but basically, like, they used to be very popular 2 decades ago or so, something like that. Till then, the mainframe servers are the core things, and they used to be huge, and people have to work with them, and they need to be technically well trying to manage them, and running them are very costly. That's why, till the .NET bubble or .NET revolution, I would prefer. So only major companies used to have their applications set up on mainframes and other things. Then people thought, no, we should expand the computing area. So they brought rack server. The revolution in semiconductors and revolution in networking and the memory and other thing basically made possible to bring out rack servers. Basically, rack servers are nothing but a server of the size of your bookshelf, or something like that, half of your bookshelf. So these rack servers have packaged computing and memory and other powers. So then they thought that, okay, they're good. We have the rack servers with us, and they are far better than our older counterpart, that is mainframes. So if you see, one second, yes. Okay, fine. So first they had mainframes, and mainframes are so big and enormous and mammoth like, and they are difficult to manage, and managing applications and deploying applications to the rack servers. Sorry, mainframes is cumbersome. So they came with the concept of rack servers, where they used to have huge racks like this, and each a big and each of this particular thing will have a rack. Okay, and the server goes here. Okay, the server goes here. So if you go to any data center in your on-prem services, or if Google for any data centers, you see rack servers. Okay, so for example, if I tell you what a servers is. Okay, rack server images, I'll show you. So these are the racks, and the server looks like this. Okay, so basically these rack servers are affordable compared to the IBM mainframe, but still they are complex, and they also need dedicated data center staff to maintain them. Air conditioning is required, huge power consumption is required. So many things are there. But above all of these things, there is one complex problem. That is, once you procure a rack server and deploy an application to it, okay, you need to set up configuration according to that particular application requirement. For example, you are deploying something like, a Python stack application, then it needs certain version of Python and certain versions of dependencies, and what set of packaging tools you need, the versioning of those tools, and pip tools and other things. Okay, so when a new application has to be deployed into the same server, then this application might might need a different configuration. Like it might need Python 3 rather than Python 2, like earlier application. So whenever new application is being deployed, it needs different configuration. So Linux has a concept of namespaces, which helps in alienating the concerns and all. And also you can create virtual environments, but still deploying multiple applications into a single rack server is becoming complex and complex. And one more problem. So let's say, uh, do you guys watch IPL, or do you guys watch Euro football or something? Any sports related event, a global sports related event? If you see, right? So what happens till the match starts? Till the match starts, you will see very less viewership, maybe few thousands of people. The moment match starts, exponentially people will throng to see the match, right? So the streaming websites, usually in India, we watch a lot of cricket. So I'll take the example of cricket. So the IPL season is going on, and there was a Champions Trophy was there. And if you can observe, the amount of viewers who are watching the sports event exponentially increase the moment the match starts. Okay, and that means it would be like few thousands to few millions within fraction of seconds, or within seconds, or within minutes. And then as the match goes by, and when crucial moments, like end of an innings, or when it comes to the fag end of the overs and all, then the more and the more viewers add on, and it would reach a few tens of millions sometimes. So in that scenarios, if you don't have enough servers, how do you cater to all those users? Understand? So let's say you have 10 rack servers. Okay, guys. Now you have assumed that, okay, I will have 1 million users approaching my application to view the match. Now, what if 10 million people tries to log in? Okay, so you cannot quickly add a rack server, right? You see, in order to procure a hardware into your data center, it is like hell lot of work. It is not so easy. You need to go to RFP. You need to set up bills and procure them. There is so much logistics involved and decision making involved. So it is not agile, it is not flexible. So rack servers are not suitable for our requirement. Then what is the alternative? Then people then the IT genius out there, they got together, and the professionals thought that, okay, let's not think about rack servers. Let's have a new solution to this problem. So they came up with a solution, that is, how about we share the resources? That means, let's say this is the rack server, one of the servers in my rack. Now, if we can share the resources, and we can spin up a machine on this rack server, and whenever we want, if we can share and spin up multiple machines on this particular server, then we can cater to optimizing the resources, and we can package more and more applications and cater to more and more users. So they thought, like, okay, let's share what are the resources of a particular server? A server contains, what do you see? CPU, memory, and storage, and some amount of networking. Okay, right. So memory means RAM here. Okay. So storage means the storage, the TBs of storage, the hard disk and other things, and networking. Now they thought, if we can share, for example, let's say it has 40 cores, okay, or 20 cores. So whatever, just randomly I'm saying. If I have like 20 core vCPU, I mean CPU, 20 cores, and I have something like 128 GB RAM, then 20 core and 20 core and 128 GB RAM, and I have one, let's say 5 TB, okay, 5 TB hard disk. Okay, now if I can share the resources and spin up missions in within this, then we can solve some aspects of optimizing our resources. So they brought in a concept called virtual machines, VM. Okay, a virtual machine is is like any other machine, except that the resources are shared with a main server which supports below it. Okay, so there will be tools called hypervisor. There is a high there will be multiple types of hypervisors, like type 1 hypervisor, type 2 hypervisor, etc. I don't want to go into deep, but basically hypervisor is a tool which will share the resources and from the underlying main server. Okay, so this is a fantastic revolution. If you see a decade ago, uh, early 2005 and 2010, you will hear that VMware is a very famous, organization which would give you VMware virtual machines, and the operations team used to call them used to love VMs. Okay, because VM can be set up, VM can you know spin up very fast, and they can work with this. But there is a catch here. Even though you have virtual machines, there is a catch here. Even now, these particular servers are still, what do you call, limited, right? So you cannot procure them, and on demand. Parallelly, during 2000, AWS, and then later on like Azure and Google, they came up with pay as you go models for renting the infrastructure to any company which wants computing resources. What do I mean? That means cloud revolution happened. To be specific, public cloud infrastructure became a reality. So huge data centers with thousands of rack servers was set up by Amazon, Azure, Microsoft, and Google. And they started saying, hey, people, smaller organizations out there, whenever you need servers, ask us, we will provide you the servers, and you can pay for the amount of resource and amount of resources you use. And then if you don't want, you can just leave it. That made possible VM revolution also thrive. But still, there was a catch. What is the catch? Whenever an application is deployed into a virtual machine, let's say this is a virtual machine. What is virtual machine? Virtual machine has certain amount of CPU, RAM, and storage, but also a core operating system within it. Okay, all the processes will be working on the operating system. Now, operating system will have kernel, and it will have a bootloader and some things which which is needed by operating system for proper coming up. So now that is called, that process of starting an operating system is called booting. Okay, so now this booting will take some time. That is called boot time. That means whenever an operation system is in sleep mode or is in stop mode, and when you kickstart it, in order to come to a stage where it will support other applications, it will take some few seconds. Sometimes in Windows it will take more than few seconds. It will take 10-20 seconds like that for properly Windows to boot and all. So Now, whenever you want to deploy and test an application, okay, let's say you are a what do you call, you are a developer and you want to test your application and you want to place this application into your VM for testing. This is called deployment. Whenever I say deployment, deployment is placing your application and that compiled or executable application into this server and making it up and running. This is called deployment. Now, whenever you are deploying an application into the VM again has to start whenever you need to restart the VM and make sure that application is properly started. So these boot times are also a headache actually. They are taking so much time, and rigorous testing needs faster and faster boot times. So VMs are not suitable for that aspect. Even another problem is that once you create a VM, you cannot dynamically scale a VM as per the requirement. That means once you allocate certain resources to VMs, and how are VMs created? On a physical server, right? So you will be sharing resources like this. You estimate that, okay, a particular VM might need more resources and particular VM might need less resources. You based on assumptions and data at hand, you create VMs. But dynamically managing VMs is also a headache, okay, because some applications might need more space because more clients might be requesting from applications within that VM, and some VMs might be underutilized. That means that amount of CPU memory we allocate to it gets not optimally utilized. So to address this challenge and the above challenge, that is deployment challenge, there come a revolution called containers. So what people thought, okay, the software development world, what they thought was, okay, let's think beyond virtual machines. How about we create a micro virtual machine which does all the things that a VM can do, but it doesn't need that, it should not need or rely on operating system on its own. Rather, like a parasite which will use the resources of the host. That means a bacteria or a virus with I'm giving you a simple example, but not think in negative context. Basically, I'm saying that how a parasite will use the host resources to grow itself and to prosper. We should have a micro virtual machine which should use the host's operating system. What is a host? Host is anything, any hardware or any machine or server which will host the application. Okay, when you go to any party, you are a guest. The organizer of the party is the host, right? So similarly, the application is deployed into any server, then the server becomes the host. Okay, so now the microservices, the micro servers or micro VMs should be created on on a server, and that host, that server, will have its own operating system, right? These micro VMs should make use of this particular operating system which is already present, so that whenever we deploy the application, there should not be any booting that should be required, and the application should be up and kicking as and when we require. So that is what the idea is. So what they made use of is they made use of basic Linux principles, and they used them to create some packaged micro virtual machines. Okay, and they are called containers. Okay, for now, for our understanding, let's stick to containers. When we go to tomorrow class, we'll understand what is an image and what is a container and all things. Okay, so slowly we will go towards understanding a step by step. We will slowly increase the depth and we will understand in depth in future classes. But for now, understand containers are virtual machines only, but in a very micro scale. What does it contain? It only contain the application and certain libraries and dependencies required for it. What sort of libraries, what sort of dependencies and all, we will learn in future when we create the containers and create the images. Basically, basically these containers are have to be created on a particular virtual machine, and they have to be run. Now, in order to create a container and run them, you need a tool, right? So this tool is called containerization tool. Docker is a very, very popular and industry standard for containerization. Okay. So what does Docker do? Docker creates this container, the source for this containers called images, and also let the containers run properly. Okay. So in order to create a container or in order to run a container, you need a container runtime engine or container runtime environment. We call it Docker. Okay. So Docker is a widely popular tool, a containerization tool. So tomorrow in interviews, when they ask what is Docker, Docker is a containerization tool which will help in building the containers and running the containers. Okay, that should be your answer. Now, how? So we have seen one of the problem, that is the problem of isolation and the problem of resource consumption and resource optimization. Let's go back to our PPT and understand that. So these rack servers are problematic when you have multiple applications with multiple versions are there. So what they brought VM era, that is VMs were brought into the picture, and the virtual machines, each virtual machines were one application. So if there is an application with Python 2.4, then they will be deploying it into a separate VM. And if you have a different application with MySQL and Python 2.5, then it will have a different VM. So like that. So they used configuration management tools like Chef and Puppet to deploy these VMs and managing the configurations. But again, what did I say? So resource optimization and booting times were a problem. So they brought into something called containers. The containers can be run on a single machine, and multiple applications can be built into micro VMs called containers and run them without any interference or without any overlap with other applications, as long as the CPU and memory and other physical resources support it. So with the cloud revolution coming into the picture, even a VM can support hundreds of containers as long as it has sufficient resources. So Docker became widely popular post cloud revolution because you can spin up a VM in AWS within seconds and install it and pack and create VM on the fly, on the go, right? So Docker became very popular because of ease of use and the way the architecture is easy to understand and work with. So guys, when we go to future classes, we'll understand what is the Docker's architecture and how Docker helps in how can we interact with the Docker Docker engine, what is Docker daemon, what is Docker client, and other things we will understand. Okay, so basically Docker CLI is nothing but a command line interface tool to work with Docker. How you open command prompt and work with commands, right? Similarly, in order to work with Docker, you need to have Docker command line tool called Docker CLI, and you work with it. So one problem is solved. That is the problem of isolation. So there is another problem called the problem of environment. What is this problem of environment? There used to be, blame game happening between developers and the operations team. That means the infra team. So what people say, developers would build the application, ship the application to any source code repository, and operations team, the infra team like us, are the early DevOps teams, I will call them. Although they don't call themselves DevOps, but DevOps is not a new phenomenon. There used to be operations team, and slowly the thought process has changed, and they include the methodology and the thought process is called, the way of working is called DevOps. So when operations team get that source code repository details and get the code from the GitHub or somewhere, when they run it in their servers for testing, it use not be working. Okay, sometimes it faces some issues. Okay, then they used to go back to developers. Hey, developers, this code is not working. Then developers used to say, no, it used to work on my machine. How is it not working? Then the issue is with your servers, and they used to blame the infra people. And infra people used to say, no, no, our infra is rock solid, and it is your code that is faulty and buggy, and it is not working. So this blame game that works on my machine is a very big headache used to happen between around a decade ago or 2 decades ago. So this is also a problem that has to be solved. What is the goal here? So what is the root cause here? The development environment where people develop the code is not the same as the environment where the application is deployed and made available to the public, that is production environment. Similarly, within development environment for one developer, that means his particular machine might be different in certain configurations from another employee, and the set of libraries and tools which used by a particular project might be different from another project. So there is so much difference between the languages, the frameworks, and the runtimes used for this particular development. So yesterday, somebody was asking, what is runtime? So runtime, as a noun, means runtime has different meanings based on the context. So when I say runtime, pure runtime, that means a verb. That means runtime is during the during the working of an application. But runtime as a noun, when you say what is your runtime, then you should tell that what is the programming language that is supporting your application. For example, let's say you are building a .NET application. .NET is your runtime. Python is your runtime. Node.js is your runtime. So runtime as a tool becomes a programming language. Runtime as a process means when it is deployed and when it is running. So don't get confused. Okay, the connotation and the meaning changes on the based on the context. So now we have a big in enterprise in enterprise scenario, there used to be very complex deployment scenarios. For example, imagine you are Jeff Bezos and our CTO for Amazon 2 decades back, and now you need to deploy your Amazon application into all these particular you know environments. Like for example, you need to cater to users who are accessing amazon.com from desktop, and the testing and QA guys has to test them. And also you need to sorry, let's assume this desktop as individual users laptop or desktop, and then QA servers, and the production cluster, that means the main servers where you are hosting the application and making the external users access this. And also assuming that public cloud is deployed, and there are your on-prem data centers, and there are certain mainframes, and there are servers and edge devices. So what am I actually concentrating on? If my application has to go into all these things, and there are several types of applications I have, okay, imagine the number of deployments I should do per day for solving for this purpose. Let's say if we have to, 1 second, guys. So if we have to cater to all these things, see the complexity involved. How many deployments I need to create and how many I need to ship. Because there was no Docker before, you need to deploy each one separately, right? One build for this, one build for this. See, imagine the amount of, build time and build resources itself, how much time it required. And in a day, there is something called nightly releases. Nightly releases means every day you will get a new release, something like that. So there are certain organizations like GitHub and other things which will release nightly. Basically, they are like very agile companies. They do a lot of development, and every day some or other new feature will be being tested in beta stages, and they will be upgraded to alpha and then go to general public uses and all. So in those companies, how do they manage all this complexity? Very difficult, right? So Docker solves this problem by containerizing and managing the complexity. You just don't need 100 builds, you just need one build. And that build is irrespective of whatever the environment you deploy As long as they have Docker or they support containers, that's sufficient. Okay, so you just need to build one static website related container and one web frontend, and one set is sufficient that can be deployed into anywhere. That is the core advantage. Now, if a developer uh, builds the code, compiles them, sorry, write the code and build it by compiling it, and builds a container out of it or image out of it, and shares it with QA with the necessary, dependencies and other things packaged into it. And as long as the container's integrity is valid, that means the image is not meddled with, then it should be absolutely same environment as developer. So whatever the developer built, the QA can test, and the same thing, if QA is passed, then it can be made available to production. So now imagine there is any bug, then they will just inform, and they will produce some hot fixes and some other thing. The regular software life cycle will move on. But what is the core advantage here? You build once, deploy anywhere. Build once, deploy anywhere. This is the core idea behind containers. Okay. So that what is the advantage here? There is no blame game. You don't call it, okay, once you build a image, you share it with the DevOps team and they deploy it into server. Now DevOps team cannot say that you have code, you have issue in your code, that's why it is not working. And also developers cannot say your infrastructure is failing, because you will have the logs, you will have the everything in your place. Once the container is up and running, you will understand if it is working fine, if it is not working fine, what is the issue. You both can sit together and troubleshoot. Okay, that's how it solves the blame game. And finally, the problem of speed. That means earlier the deployment speed was very slow when it was mainframes, and from mainframes it used to go, it moved to virtual machines, and from there to from mainframes to rack servers, and from rack servers to virtual machines, and virtual machines to cloud, and finally cloud to container. So when you see this, the amount of deployment time drastically reduced. Okay, if you say, for example, in the 90s, they used to deploy it into mainframes, then the deployment would take a day, okay, or several hours. When it came to rack servers, it came down to few hours, and from there to virtual machine, it came to few minutes. And now you can deploy within seconds to your production grade clusters by using containers. So container is very lightweight, and it can be deployed within seconds, and it will start up within few milliseconds. So there is the problem of speed, that is how the velocity of deployment has been revolutionized by Docker. If you can see the amount of time that is saved. So these are the problems that are solved, and these are the advantages we will get. We have accrued because of Docker. So by combining the ideas of images, containers, and then registries, all these terms you will understand as we go by. Image is a static one. When you take an instance of an image and run, it becomes a container. And when you want to save the image somewhere securely, that is place called registry. Okay, so there is nothing fancy about these words, but you will understand much better going forward. And the necessary tooling when it is packaged with the image, so it helps a life cycle in developing faster, building faster, testing faster, deploying and updating and recovering faster. So rolling back an application if it is not working properly is also very easy when you have Docker. So there is huge reduce in maintenance costs, and 90% reduction in maintenance cost compared to rack servers, 70% reduction in VM costs. And this is not my statistics, guys. I took the statistics from Gartner's. Gartner is a widely popular, knowledge. What do you call, knowledge archive, where they produce several articles which CEOs and CTOs refer to for guidance and all. So Gartner publishes their Gartner index, and one of the Gartner's data suggested these advantages because of containerization. Okay, so coming here, so basically what are the problems are the same thing I want to summarize. So if we want to, we want independent standardized application packages. So even if there are different environments, we want to build and test exactly the same environment as as we have done earlier, and we want to use the same testing to be done in other environments. Similarly, every team member should have exactly same environment when they package and build it. How do we achieve it? There is something called Docker file. We write the instructions in declarative format, and we will tell the Docker to build exactly the way, so that wherever you have the Docker file with the necessary code, it will be standardized, no meddling between. So similarly, there are tools, and multiple tools cannot clash because you have isolation between containers and other things. So this is for today, guys. So I hope you have understand why do we need Docker, what problems it solved. So with this history, tomorrow when we go and understand Docker's architecture, you will understand much better the architectural components of Docker and how Docker helps. So tomorrow will be the last demo session. And if you find this particular course and the pedagogy, the way I'm teaching understandable to you, and if you feel that this course is going to add value to you, kindly register for the course. And most importantly, I'm going to provide this additional bonuses along with this course. One free monitoring course, Prometheus and Grafana, has been provided to you. At the end of the course, you will be given access to this. The reason is logistics issue. So the course is already there, videos are already there. You just need to go through it. When any interview, if you go, they will be asking what monitoring tools how do you analyze your system's performance. So if tomorrow you are a Kubernetes expert, how do you understand and monitor the Kubernetes? Using Prometheus and Grafana. So basically this course is going to help you in understanding observability and metrics and visualization things. So I'm going to give you free of cost this course. Whoever registers for this particular Docker and Kubernetes, you will get this free of cost. And I'll be providing you sample resumes so that you can incorporate the aspects of those resumes into your resume so that you can make it more relevant. Because industry now is moving towards more and more automation, and they need Docker and Kubernetes must. So I will providing you profiles and resumes so you can incorporate them and reuse them. And I'll be providing you industry relevant end-to-end real-time project, which you can uh, put it in your GitHub repo, and you can showcase it to your prospective employers. And then I'll be, for those enthusiasts out there, if you want to do any certification, there is a famous certification called Certified Kubernetes Administrator, CKA. I'll be providing you certification dumps for that as well. And as Azure and GCP certified architect, if you need any help regarding those certifications, let me know. I'll be sharing those dumps with you. And obviously, every now and then I'll be sharing with you interview tips and techniques. And there is a course I'm delivering. I'm about to deliver in a month or so. I'm planning to do that, and I will also see to it that you will get access to that. Okay. And finally, any latest updates that will be provided to you as and when the course is on the way, and also post the course completion. Any new updates, I will be making a video and make it available to your portal. So any doubts, guys? Any doubts? Do you need any clarity regarding this? Let me know. In the meantime, I want you to join the WhatsApp group, and also I want you to register by paying from this link. Okay. This is WhatsApp group, and I will be also sharing the link to the payment page. And this is the payment page. So if you are happy with the way the class is going, and if you are interested in for getting the full benefits of the course, like recordings, notes, and all the bonuses, then kindly register and go ahead. Any doubts, guys? The floor is open for questions. Any doubts? Anand, Arun, hi Balu, hi Monish, hi Mustafa, hi Pawan, Sam, Sao, Paul, Satish, Syed Raksana, Sheikh Syed, and Thierry. Yes, Anand, 1 second. Yeah, you can unmute and you can ask your query.
Yeah, hi.
Yeah, there is a small echo, but I can hear you.
How this course will help after the completion of this course to get the job in
Hmm.
Kubernetes?
May I know your background?
Yeah, Oracle Apps DBA.
Okay. Are you trying to switch your career or you want to pursue in the same DB related
No,
area?
no, I need to switch the career.
Yeah. So one opportunity will be you can become a DevOps related, since you have 10 plus experience, you can move into platform related areas. And nowadays they are deploying DBs as containers into Kubernetes clusters. So that is still, people are, there is something called stateful sets and other things which we will be discussing in classes and all. So your DB knowledge is helpful there. And also when you go to job, right? For example, you want to switch to DevOps role or platform role or SRE role, you must know Docker and Kubernetes. Without a Docker and Kubernetes, just don't take my word. Just go to LinkedIn or Naukri. Just search for this, whichever the dream role you are looking for, or the role you want to switch into. Look for any containerization or orchestration words. If you see Docker and Kubernetes, that means this course is going to be absolutely helpful to you. And I am sure 99.99% that you will not see any job requirement without Docker and Kubernetes for DevOps platform and SRE, and even for Java full stack they are asking. Okay, so
Okay.
this will be a
Yeah,
very
completed AWS DevOps as well, Vijay.
very good, very good. So this will be added advantage to you, Anand.
Okay,
So
okay.
now you have AWS DevOps, right? So
Yes.
now our course will be demonstrated on AWS platform itself. So that knowledge will be also be added advantage to you while creating the VMs and working with AWS EKS clusters.
Yeah, one more point here. So in DevOps, I learned all these things, whatever you said, the Docker and
Mhm.
Kubernetes, Terraform.
Mhm.
So
Yeah.
I want to learn in depth actually. So that's why I'm joining this course.
Yes, yes. As I said, the course contents, if you see, we have covered in depth. I'm not giving you, high level fundamentals. It goes in depth from scratch to the level of advanced. For example, once you complete this course, instead of a fresher, you will be on par with someone who has worked with Docker for like so 3 to 5 years. So that level of knowledge I'm going to share with you guys.
Okay, okay.
But I
So it
want
will help
in
to me,
return you
right?
need to, yeah, you need to practice as well. Okay, that
Yeah, yeah.
that yeah.
That
Once
is
you
must.
practice those labs, I promise you that you will be much more comfortable as an experienced DevOps engineer. Yeah.
So my entire career is in Linux only actually, 13 years.
Fantastic, fantastic. Then you will work with ease and you don't need much. Many of the labs will have certain introduction to how to work with Linux and certain Linux commands as well. So you don't need also those things. You will quickly, you know, get the concepts very simply. Yeah, very easily.
Yeah, yeah.
Sure,
Thanks,
sure,
Vijay.
Anand.
Thanks for your information.
Definitely
Yeah,
looking forward to see you through the course. Yeah.
sure.
Sure. Kindly mute yourself. So anybody else? Anybody has any queries? Thierry, Ruxana, Syed, Paul, Masani, Satish Masani, Pawan, or anyone? Mohnish has the. Anand, if you have no questions, can you lower your hand so that I will address others' concerns? Yes, Mohnish, you can unmute and you can ask your query.
Thanks, Vijay. Thanks for the nice session.
Sure.
So I am basically cloud administrator, and
Good.
I have my overall career into Windows, right?
Mhm.
Windows and Azure. Now
Yeah.
I don't have any background as such into Linux.
Okay.
How so? Do I need to spend any time into understanding the Linux concepts or
I will be
commandlets?
sharing with you. Yeah, I will be sharing with you certain resources. You
Mm-hmm,
can go through those resources. What you need to know is some basic Linux commands initially, and as
mm-hmm,
we proceed, the resources I'm going to share with you, just do a cursory read through, or if you want, if many people want, I can take a 15 minutes to 30 minutes session on Linux fundamentals so that you can get a refresher understanding. But Linux is not completely a prerequisite for this, but having few commands, knowing few commands and how to work with Linux virtual machines would be an added advantage. But even if you don't know that, just let me know that I will give you the necessary foundation.
Got it. Got it. Got it. And then, so basically, Docker, you mentioned it is a containerization, and I think Kubernetes is a orchestrator.
Right.
Is that right understanding?
Yes, correct.
Okay.
Absolutely.
So now, basically, we have certification for Kubernetes. So do we need to have do we need to go for another certification for Dockers as such, or Kubernetes certification will cover
in
that?
industry, in my I have been part of several panels, interview panels, and 99% of the time they are looking for CKA, not for Docker engineer certification. Because the concepts of CKA involves Docker. Without Docker understanding, you cannot pass CKA. That's why.
Right. Got it.
Yeah.
Okay. Thank you.
Yeah, sure. Definitely. Please lower your hand if your query is resolved.
Yeah.
Excuse me. Yes, Mustafa, please go ahead. Unmute yourself and ask your query.
Yeah. So, in my organization, right? So we are using Azure basically. So we have a ACR. Okay. So we are from our Jenkins, and we are pushing to ACR. Okay.
ACR.
And then it is we are pushing to Kubernetes. Okay. So I know till Docker, but I'm not aware of Kubernetes. Okay. So that's why I'm joining this code. This is the point one. And the second one thing, we are doing migration from Jenkins to Harness. So we have implemented Harness. I think you are aware of it, Harness.
Yeah.
Okay. So we have started the migration also from Jenkins to Harness. So Harness is a self-service place tools where everything is get automated, and app developers will onboard their application and deploy their application and put their secrets, each and everything. So like that, now we are going to practice in ACR container registry in Azure, or like how you are going to show it in your classes. That's I want to know.
Okay. Most of the course will happen in AWS, but the creation of clusters and using the VMs, that I can provide documentation for Azure as well. That is the first question. Since you are new to Kubernetes, I want to tell you that the concept of the Kubernetes will not change between platforms, whether it is Azure Kubernetes Service or Elastic Kubernetes Service or GK, Google Kubernetes Engine. The concepts remain the same. Certain few aspects of managed Kubernetes and certain add-ons and the way we slightly configure it might vary, but the fundamental principles how you work with doesn't change. So the concepts which I'm going to teach you in the Kubernetes, this is for your first question. Okay. Teach you will be relevant to you even if you go ahead and work with AKS as well.
Okay.
Second thing, you are going to use Harness as a DevOps tool, right? So basically, any new tool that is coming, they are following something like a GitOps process. So GitOps process is something like using certain principles and frameworks which developers use to work with GitHub or Git. And the same principles have been used for infrastructure related utilization, like you will automate the things and you will orchestrate the things and several other things. I cannot specifically teach Harness because
no, I'm not going to learn Harness here, but just from Harness we are deploying to Azure Cloud. That is the one thing, and we are implementing AWS federated. Okay. So that implementation is going on. We have done the POC, and that implementation is going on. So going forward, like like from our JFrog Artifactory, we are going to deploy to the AWS container registry. Then it will be going forward. That is the implementation plan actually.
So if I get you correct, are you migrating from Azure to AWS? Is that what you are mentioning?
No. We are not going to migrate to no. So we have some application will be in Azure, some application will be in AWS. Not like
great. Then
and everything will be done via TFE, not via these things. And everything should be done via TFE.
Obviously. See, even we in our course, after initial setup, I'm going to share you the TF code only for the cluster. So
Yeah.
you don't need to create a cluster and keep it running. That is useless, right?
Yes,
Now you
correct.
want to test it, just do a Terraform plan and apply and then destroy.
Correct,
Then
correct.
again
So,
break. So I'm going to share you TF based approach only. Even for
but
Docker, I'm going to share you certain TF related commands and the TF files, and you can use them for your purpose. I I as a architect and a lead, I promote anything should be based on infrastructure as code only. Whether you use TF or TF Grunt or basically the industry leading tool is Terraform. So I will be providing you that aspect as well, along with certain Helm charts and other things. Some deployment related aspects for your specific question, the
yeah,
deployment strategies and other things I will be teaching you during the uh, end-to-end project demonstration. Till then, please bear with me because others cannot understand. For the sake of the course and your cohort, your peers, so they will not have much understanding. So I'll be taking up the deployment strategies. That is an advanced concept. Like by taking an Argo CD, I will be demonstrating the canary based and other based deployments, and
yeah.
you will understand them better at the end of the course.
Okay, got it. One last question.
Sure.
Sorry, one last question. So,
Yeah.
like just now, you told like you are going to teach some Linux command. Okay, that is well good.
Mhm.
Everything extra knowledge is very good. So, like, are you going to teach some basic command for TFE also, as it is for like how you are going to tell for Linux?
For
Do you have
Terraform, you
any
need.
plan? Yeah, for Terraform also.
If some of you need it, let me know. I will take up. Not an issue at all. Yeah,
So
shoot.
like it's like basically like how you are you just now you told for Linux, like it will be very
Yes.
good for everyone, not even for
Okay,
me.
then
Like
I'll
same if
take
we
up.
go in a
Just remind
Terraform
me.
also, it will be good. Yeah.
Yeah,
So that's what I
remind me after any week, because initial classes would be working on certain tools and
sure.
playgrounds. Then you don't need TF. The moment I work with setting up a Docker environment and setting up Kubernetes environment, I will take up a 15 to 30 minutes quick refresher session kind of thing to give you the basics and working with those things.
Okay, sure. Thank you.
And also, Mustafa, so whenever you find any tool or anything uh, uh, little complex and you are not able to understand, or any guys, you guys, any
Yeah.
difficulty, just put it in the chat, and I will try to address that issue in much deeper. Okay,
Okay. Yeah.
cool then. Can I proceed to next person, Mustafa?
Go ahead. Yeah, go ahead. Thank you so much.
Yeah, sure. You are welcome. I'll
Thank you.
mute you and I'll go to Ruxana. Hi, Ruxana. How are you doing today? You can unmute and you can ask.
Hi Vijay, hello.
Hi.
Vijay, the question is, I'm currently working for middleware technology like Apache, Tomcat, WebSphere, and all.
Okay,
In
great.
order to move to the cloud technologies, actually, I have little knowledge on AWS. But the thing is, I don't have hands-on experience.
Okay.
So, and apart from that, like for this Docker and Kubernetes, what type of questions they will ask? Like more on the Docker side or more on the Kubernetes side?
It depends on the role, Ruxana. For
Hmm.
example, you are going, what experience level may I know?
It's 8 years of
And
experience.
then you will be grilled on both. Okay. So you will be expected to know in depth about both Docker and Kubernetes.
But
But
I
most
want
of
to
the
keep
questions will be
only
on.
for 4 years, not totally 8 years. So I
Okay.
keep it.
Okay. Then there will be equal representation from Docker and Kubernetes, but more or less on Kubernetes you will get questions. Okay. So the more and more experience you gain, the more and more you will be expected to set up Kubernetes clusters. See, understand. Without Docker, working with Kubernetes is like, without knowing the recipe, cooking something. You cannot cook something without properly understanding the recipe. You want to make tea, Ruxana. You want to cook something without knowing how to boil milk and how to add and where the sugar is there and how much quantities to add. You cannot make proper tea, right? So any dish. Similarly, without working with Docker and understanding the basics of Docker, usually people cannot work with Kubernetes unless you are in totally automated environments and you have OpenShift and all, and you have certain other tools like one of our friend was mentioning, harness and such things. But in a regular environment, you need knowledge of both of them in depth, because as a DevOps engineer or a platform engineer, you will be expected to take the code. Developers will only tell you, okay, Ruxana, this is my code base, and please give me the image, or please deploy this application into Kubernetes cluster. They'll just give a word. Now it is up to you to know how to pull the code, how to generate images, how to push it into repository, how to pull that from repository to your cluster, how to make it up and running, right? So this entire life cycle, or supply chain, you need both knowledge of Docker and Kubernetes. So I'm see, I'll be going to give you, my documents will be like step by step. See, one of the document I'm sharing with you. This is of the latest one. Just wanted to give you a demo. See, it has every step by step. You will have each command given to you. You don't need to know in depth about, Linux commands also. You just need to know how to run the commands. Then you can Google the command and understand the concept behind it. That's definitely. But while demonstrating, I will be explaining the commands anyway. So in one way, yes, you don't need in-depth understanding of Linux and cloud, but having knowledge and Googling this thing, and you know what, this is to all of you basically. The only skill I want you to know is how to work with ChatGPT and Google. Okay, the only skill I expect from you is to how to Google things when some things doesn't work. Sometimes I give you a document and some update comes. See, every minute there would be some or other upgrade happening to AWS environment. So sometimes if version changes happens and all, you should be able to Google and figure out that, okay, new version came, the old one got deprecated, and some things like that. Okay. As long as you are good with Google and Google, then it is fine. You can learn this course.
So, but the thing is, like, they already set up everything. Like, we no need to set up and do the things, but only we have to do the some configuration things and some upgrades or any certificate things. So, these things we need to do on the environment side. Like, once
Sorry, I didn't
we
get your
use
question.
the
Can you come again?
other, like this thing.
No, Ruxana, I didn't get your question. Can you please
No,
clarify?
no, no. The thing is, the installation part they already done. Like the other people who are there in the project level. So, like what I'm saying, the Docker installation, Kubernetes installation, they
Yeah,
already done on their
they created the
environment side.
clusters already.
Yeah, that. But we need to deploy whenever
Right.
they are saying like we need to deploy the images onto the like from
Yeah.
the
Registry.
from the registry.
Right.
So same questions they might have asked, and at the troubleshooting part also they might have asked in the
Yes.
interview side.
So this course, in this course, from like from after the Docker, right? When we start with Kubernetes and setting up of Kubernetes, while working with different components of Kubernetes, we will be looking at these aspects like while deployment, what kind of issues might arise, and there will be a dedicated troubleshooting session for 2 hours where we will be discussing scenarios, because in interviews they will ask scenarios. For example, they will ask you, let's say you deployed an application and pod is not coming up. How do you troubleshoot? This is a scenario. So we will cover extensively about several scenarios about Kubernetes and Docker during the troubleshooting session, where you will be, getting what do you call it, very good idea about how to address those questions in interview.
Yeah. Yeah. Good.
And obviously, like in not every project you will be given a ready to work with containers, right? Sometimes you have to build containers yourself, sorry, clusters yourself. So it is also important that you learn how to set up clusters in different
Yeah,
environments.
from the scratch they will ask some
So
projects.
we will be dealing with multiple strategies to create a cluster in multiple environments. So you will get an in-depth understanding of how to set up and how to address those interview questions as well.
Yeah, sure. Thank you. Thank you.
Sure, Ruxana. Ruxana, thank you so much. I'll mute you. So Anand, do you have any other question, or you have by mistake you have raised your hand? Okay. Okay, guys, that's all from today. So kindly go ahead, and if you feel that this course adds value to you, then kindly register for the course and let's join tomorrow to understand the Dockers, working. Okay. See you. Tata. Bye bye. Take care. Have a nice day ahead.